Okay, welcome to Mr. Hassan's Maths channel. In this video, I'm going to be answering question number 8 from the Pure Mathematics P2 International A-Level Edexcel January 2020 paper. And this question, the part 1 of it, is about proving the formula for the sum to n terms of an arithmetic series. So it states an arithmetic series has a first term a and a common difference d. Prove that the sum to n terms of this series is n over 2 times brackets 2a plus n minus 1 times d, close bracket. Okay, before I go into the proof itself, I want to just show you something that will hopefully make you understand the proof in a better way. And there's a little story behind this, and it is of a student who was in primary school by the name of Carl Friedrich Gauss in Germany in the late 1700s. And his teacher had some work to do, had some marking to do, I guess, and the teacher was behind and wasn't, wanted to finish off that marking before they actually started teaching the class. So the teacher thought of a way to try to keep these students busy doing something and quiet, so that he or she could finish off the marking of the books. So the teacher told the students to find the sum of the first 100 integers. So 1 plus 2 plus 3 plus 4, and the teacher assumed the students would start 1 plus 2 is 3 plus 3 is 6 plus 4 is 10, and go all the way up to adding them all the way up to plus 97 is whatever, plus 98 is whatever, plus 99 is whatever, and then get all the way to 100. Plus 100. Okay, and of course write all of the numbers in between, and that would take them a good few minutes to do, maybe half an hour or so, and the teacher would finish the marking, and then everything would be fine. Maybe the teacher didn't even know the sum themselves. Anyway, back to Carl Friedrich Gauss, who was a primary school student. This is primary school. Wasn't even secondary school, not university level. This guy, within a few minutes, put his hand up and said, "I've finished, teacher." And everybody was completely shocked. How could you have finished already, adding up the first 100 numbers? So the teacher asked him to show the class how he did it. So he basically wrote down exactly like this, a few numbers on this side, and then he put didn't put any other numbers, then he could put the numbers at the end. And he said, I noticed a pattern that if I write the numbers in reverse underneath the numbers on top, I noticed that there's a pattern that we can start using. So he said, okay, I'm going to write 100 plus 99 plus 98 plus 97 plus ... And then here you're going to have 1 going backwards, plus 2, plus 3, plus 4. Okay, and of course, if the pattern holds for those, it will hold for the rest of the numbers. So he didn't write, all the other numbers, of course. But then what he notices, if he takes these two lines and adds them together, so you have 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. And of course the same applies in reverse. So you're going to have all of these numbers add up to 101. 101, 101, and 101. So basically, altogether, how many 101s does he have? Oh, there's 100 numbers that he's written down. Of course, he didn't write them all down, but this is the first term. That was the 100th term. So there's 100 numbers written down. So there's 100 times 101. However, this is the sum of the first 100 terms. And this is the sum of the first 100, I should say integers. Okay, but just written down backwards. So when you add them together, you're going to get 2 times the sum of the first 100 integers. So you know that this is twice the sum of the first 100 integers, which is going to give us this. So the sum of the first 100 integers must be 100 times 101 divided by 2. Okay, it's probably easy if we do it like this. 101 with 2 zeros at the end, divided by 2. And if you do division here, remember they didn't have calculators in those days. 2 into 10 goes 5 times. 2 into 1 goes 0 times, remainder 1. 2 into 10 goes 5 times, and you got a 0 at the end. So 50/50, 5050 is the sum of the first 100 numbers. And that's how this Carl Friedrich Gauss came to this particular sum, and the teacher was completely shocked and didn't manage to finish their marking on time. Okay, so that is the basis behind the method we are going to use to prove this formula. We haven't proved this formula, but hopefully we've understood the process that we have to go through in order to prove it. Okay, so I don't want to just teach you write this and then write this and then write that, and you know you're going to get the marks because you know the examiner will see you've written down the correct things. I want you to understand the basis behind it, and that's the purpose of me making these videos, not just to explain how to get the marks, but to understand what's behind what the maths is behind it, so you can have a better understanding. And when you understand things, you tend to enjoy them more. Okay, so I'm going to now cross all of this out, and I'm going to start again, but this time I'm going to use these algebraic terms instead of these real numbers. Okay, so let's get rid of this. All right. Okay. Now, it says an arithmetic series has a first term A. So the first term is A. The second term, and a common difference D. That means to get to the next term, you have to add the common difference. So the second term is going to be A plus D. And the third term is going to be A plus D plus another D. So that's going to be A plus 2D. And the fourth term is going to be A plus D, A plus 2D plus another D, which is going to be A plus 3D. Okay, so if I want to find the sum of these, I've got to add them together. That plus that plus that plus, and let's think about the nth term. All right, here, n, the nth term. Okay, now for the nth term, okay, we got to look at the pattern here. If it's a 1, it's A plus 0D, basically. If it's a 2, it's A plus 1D. If it's a third term, it's A plus 2D. If it's a fourth term, it's A plus 3D. If it was the 10th term, it will be A plus 9D, one less than that number. So this is going to be A plus, and not N, but 1 less than N. So A plus N minus 1 times D. That's the nth term. Okay? That's the nth term. And the term before that, which is the N minus 1th term, is going to be 1 less than this. It will be A plus 1 less than N minus 1 is N minus 2 times D. Okay, and I think you get the idea. This will be A plus N minus 3 times D, and so on. So you're going to have all the numbers from 1 up to the nth term. They will look like this, and then we're going to reverse the sum. So the first term, I'm going to write the last term. So it will be A plus N minus 1 times D. Plus, and then you'll have A plus N minus 2 times D, and I'll have A plus N minus 3 times D, and so on. Let me just get rid of this one so that I think you got the idea. I don't have too many of these things written down. Okay, so like that's like the nth term and the N minus 1 term and the N minus 2 term, all right, written down like this on top of the first, second, and third term. So this is the sum of the first n numbers written in the ascending order, and this is the sum of the first n numbers written in like reverse order. So if I add them together, this will give me 2 times the sum of the first n numbers is going to be, now if I add these two together, I'm going to get A plus A, which is 2A, plus N minus 1 times D. Now if I add these two together, A plus D plus A plus N minus 1 times D, I should get the same thing, because we realized from before that you're going to get the same thing. But I'm going to just prove it to you down here somewhere so that it's out of the way. So it's a plus d and a plus n minus 2 times d. So I have a plus d added to a plus n minus 2 times d. Now let's see, if we expand this, you've got a plus a, which is 2a, the 2a parts there. Then I've got plus d. Then I've got, if I expand this, I've got plus d times n minus 2d. Okay, so now I've got 2a, and I've got plus d times n, and I've got d minus 2d, which is minus d. So if I take out here the common factor of d in the second pair of terms there, I'll have 2a plus, and I'll have d times n minus 1, which is the same thing as 2a plus n minus 1 times d. So you can see it's exactly the same thing. Plus 2a plus n minus 1 times d. And it will be the same all the way until the end. You'll have 2a plus n minus 1 times d. And the plus 2a plus n minus 1 times d. Okay, so that's what you're going to have here. And basically, you've got altogether n terms. So 2 times the sum of the first n terms will therefore be n times 2a plus n minus 1 times d. And therefore, the sum of the first n terms is going to be a half of that, because you've got to divide by 2. So let me just get rid of this. Alright, so the sum of the first n terms, therefore, is going to be n over 2 times 2a plus n minus 1 times d. And we've proved this formula. This formula is actually given to you in the formula book. Okay, we've proved this formula, and that's that. Now, there's something else that I want to show you, which is related to this, and related to the next question, actually. So we've actually, we finished this. I went through a lot longer than of course, in an exam you would, going through this question, because I wanted you to understand the basis behind it. And the best way is to do it with those real numbers that we had, which was the sum of the first 100 terms. But there's something else I want you to understand, because there's also another formula that tells us the same thing. And that formula is based on this formula, because if you just split this up, you get Sn equals n over 2. Now, if I write this as a plus n minus 1 times d. Okay, if you notice, this is the first term in the series. If you go back here, the first term in the series is a. This is the first term. You can say u1. And here, this is the last term, which is un. Okay, so if we have the first term in an arithmetic series, it has to have a common difference. It has to be going up or down by the same number each time. Then an alternative formula for it would be n over 2 times the first term, which is a, plus the last term, we'll call it L. So if you know the first term and the last term, and you know the number of terms in the series, you can also find the sum of the terms in that series. Okay, so that's another formula that's really useful, and this is how it's derived. Okay, so now let's go on to question part 2. Okay, now for question 8, part 2, about sequences. It's given us a sequence u1, 2, 3, and so on. It is given by un equals 5 times n plus 3 times minus 1 to the power of n. Part A says find the value of u5. So basically, simply we replace the n with whatever term we're looking for. We're looking for the fifth term. So we replace the n with 5. So it's going to be 5 times 5 plus 3 times minus 1 to the power of 5, which gives you 25, and you have plus 3 times. Now, when you raise a negative number to an odd power, it becomes negative. Okay, the whole thing is raised to this power because you have an odd number of negative numbers multiplied, so there'll be one minus left over when the others are combined to give you positives. And minus 1 to the power of anything, it's going to stay minus 1 basically. It's just going to be minus 1. If it was an even power, it would become plus 1. So 25 minus 3, 25 minus 3, which is 22. So there's your answer to part A. Pretty straightforward. Part B now, it says find the sum between n equals 1 and 59 of un. Okay, so basically you got to find the sum of this whole sequence, 5n plus 3 minus 1 to the power of n. You got to find the sum of, all of these numbers. So like the first term would be 22. The second term would be what you get. So the first term would be when you put 1 in here, which would be 5 minus 3, which would be 2. And the second term was what you get when you put 2 in here, which would be 10 plus 3 times 1, which would be 13, and so on. So it's like you have to add all the first 59 terms together for this series. Now we could generate all the terms and then add them together, which would be a bit ridiculous, takes too long. Or we can think about how can I rewrite this series in such a way that makes it easy for us to find the sum of the series. Okay, now I can see that this series is of, you have something plus something else, like two separate terms in this series. So what you can do with series, really helpful, is you can split it up into parts. So I can split this up into, between n equals 1 and 59, the sum of 5n separately from between 1 and 59, 3 times minus 1 to the power of n. I can split it up like that. Okay, and just like even with integration and differentiation, you can split it up in separate, you can deal with them separately when they're different terms. So I can deal with them separately, then add them together. I can find the sum of this and find the sum of that and then add them together. And what makes it even easier still is just like with integration, I can write the constant outside the sum. Like, for example, if I have 5 plus 10 plus 15, okay, just look at a small example, 5 plus 10 plus 15. I can see that's going to give me 30, right? And if I take out 5 as a factor first, so I have 5 times 1 plus 2 plus 3, okay, that's going to give me 5 times 6, which is also 30. It's the same thing. So I can write this here, okay, as 5 times the sum of the first 59 numbers, n equals 1 to 59. And it will give me the same as, the sum of the first 59 terms of 5n. When you replace the n with 1, 2, 3, 4, 5, and so on, it can be the same thing. Okay, and similarly here, I can write this as 3 times the sum of, from n equals 1 to 59, of minus 1 to the power of n. So now what I can do is I can deal with these two separately. Okay, I can deal with these two things separately. Whoops, what did I do there? Okay, so this now becomes quite easy. So I'm going to just now focus on these parts and then I'll put it together in the end. I'm going to focus on these parts and then I'll deal with the 5 and the 3 in the end and just put it together to find the final answer. So I'm going to look at the sum of the numbers between n equals 1 and 59 for n. And so that's basically going to be 1 plus 2 plus 3 plus 4 plus all the way up to 59, which is a very simple arithmetic series, okay, which we can find the sum of the first 59 terms very easily. And we can use, in fact, this very easy formula, n over 2 times a plus l. We could use the other formula, n over 2 times 2a plus n minus 1 times d, but this is way easier if you know what the first term is, you know what the last term is, and you know the number of terms. And we know all of those here. So we say the sum of these 59 terms is going to be n, which is 59, over 2, times a, which is 1, plus 59, which is, plus l, which is 59. So that's going to give me 59 over 2 times 60. So it's 59 times 30. Okay, so 59 times 30 will give me that sum. So you have 59 times 30, 1,770. So that's 1,770. So I can say that the sum from n equals 1 to 59 of the first n terms is going to be 1,770. Okay, so that's that part here. Then I'm going to look at the second part here, which is the sum from the first to the 59th term of minus 1 to the power of n. All right, so here we can see that the sequence that's going to be generated is the first term will be minus 1, the second term will be plus 2, the third term will be plus 1, plus 2, minus 1 squared, which is plus 1, and then the third term will be minus 1 cubed, which will be minus 1. The next term will be plus 1, minus 1, and so on, until you got to the last term, which is the 59th term, which will be minus 1 raised to an odd power, which will be minus 1. So the first, second, third, fourth, fifth, up to the 59th term, we'll notice that each of the even terms is positive, and each of the odd terms is negative. Right? So you have 59 terms. Right? So, you know, you starting with a negative term, you're ending with a negative term. So basically, all of these will become zeros. Minus 1 plus 1 will be 0. So 1 plus 2, the first and second term, 0. Third and fourth term, you add them, 0. 5 and the sixth term, 0. All the way up to the 58th term, you add all the terms together, you're going to get 0. You'll be left with minus 1. So we can logically work that out. But if you can't think about that logically, you can revert back to the formula that we know. This is a geometric sequence. Why? Because you have a common ratio. If you divide a term by the term before it, each time you get minus 1. So it's actually a geometric sequence where the first term is minus 1. The common ratio is also minus 1. And we know that the sum of the first n terms of a geometric sequence is given by the formula a times 1 minus r to the power of n all over 1 minus r. So that should give us the answer minus 1 as well, although it's not really necessary to use this, but we can, you know, show that it will work because this is a geometric sequence as we've seen. So a is minus 1. You have 1 minus, and then you have minus 1 to the power of 59. That's r to the power of n, because we're looking for the sum of the first 59 terms, over 1 minus the common ratio, which is minus 1. Okay, so that will give us minus 1 times, and you have 1 minus minus 1. Remember, you raise something to an odd power, minus 1 to an odd power stays as minus 1. So that's going to be 1 minus, and that will stay as minus 1, over, and you have 1 minus minus 1, which is 2. So you have minus 1 times, and you have 1 plus 1, because the minus will become plus. That's going to be another 2 there. So these 2's cancel out. So we're left with exactly what we said. So the sum of the first 59 terms of this sequence is minus 1. So we can say that the sum from n equals 1 to 59 of minus 1 to the power of n is equal to minus 1. So now we can put it back into this. So we have 5 times. We have 5 times. So we can let's write it out from the beginning. So you have n equals 1 to 59 of the original thing that we're trying to find is 5n plus 3 times minus 1 to the power of n. 5n plus 3 times minus 1 to the power of n is equal to 5 times the sum of, as we said, n from n equals 1 to 59 plus 3 times the sum of minus 1 to the power of n from n equals 1 to 59, which we've now found. This is 5 times the answer that we got up there, which is 1,770, plus 3 times the answer we got here, which is minus 1, and that will give us our answer. So we have that times 5, and we've got to subtract from that basically 3. And that gives us 8,847. So that's a nice, easy way of dealing with this question. You know, just splitting it up into its separate components. That's something that's actually very important for you to know. It's kind of the same with integration, all right? And a lot of people ask that question, especially when we have questions dealing with trapezium rule and how you can rewrite something in terms of the answer to part A. These kind of understandings are very important for us to understand that when you have separate terms for sigma notation, you can write them as 2 separate sigma notations, added or subtracted. And when you have a multiple, that multiple can be written outside the sigma notation, just the same with integration. So, you know, just the same things. And I kind of hopefully showed you how that works. So that's a nice, easy way to do question 8, part B. There's another video which I've shown, which I did a few years ago. I mean, I've replaced something that I did earlier with this. I think this is different from how I actually was showing it in that earlier video, but I replaced that with this because I think that was not complete, and for some reason the video stopped and I couldn't find the rest of that video anywhere. And I think this is an easy way of doing it anyway. So this is a few years later. I've replaced that for this. This is for part 2. But there is still another video where I have got like an alternative method using just the patterns to do part B as well, which I'll keep up as an alternative video. I'll put the link for it at the end of this video. So I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from this topic of series will be found in the videos. The link over here, playlist will be there, and you can subscribe to my channel by clicking on this link. And the video at the top here will take you to the alternative method of answering this question, which I put in a separate video, which did some time ago. Thank you for watching, and see you soon.